Okay, I'm going to talk about the FunCube USB dongle, and let me just pop it onto the next slide. What is the FunCube dongle? It's a ground station receiver for FunCube, and at all times I wanted to consider what are the primary goals of what we're trying to achieve here. Well, FunCube has got education outreach, as I think you're going to hear Michael discussing further in a little while, and it needs to be accessible. I don't want to have this thing where people have got a pound of spaghetti wiring to plug into their computers. I mean, it's all great for inquisitive radio amateurs, but I don't want to preach to the converted. I want to preach to people who have possibly see it as a little bit intimidating, and they just want something to just get them on board. I wanted something where it was also low cost. So not only was it technically not intimidating, it was also not intimidating on the wallet. So the question is, how do we do that? Well, I wanted to have some way of being able to gather and receive the signals coming direct from the satellite, and something that you could just plug in and go. So what we had in mind, probably can't see that picture down there, which is unfortunate, but if you can see...
The chair's in the way. Where's the chair?
Yeah. Does this work? Okay, so here's our FunCube satellite, and I've done more than one satellite because we might want to use it for other satellites as well. Here's a data warehouse which holds a whole bunch of telemetry information that people have downloaded. Here's somebody's PC which is sending the data into the telemetry warehouse. We have to have something between the satellite and the PCs so there could be hundreds, if not thousands, of people downloading telemetry across the globe. But we need to have something that they can use for receivers. Now, as radio amateurs, we probably have receivers and ways of being able to do that. But Joe Average doesn't have that, and possibly doesn't want to spend several thousand or certainly hundreds of pounds in doing so. So we wanted something that was going to perform the reception capability that was easy to use and reasonable cost. And the first thing that came to mind was, probably can't see in the picture down there, but a USB dongle. So essentially, if you can imagine a DVB USB adapter, so it allows, say, a Win TV, so you can watch TV on your laptop. So we could consider something like a USB device which had an aerial on it. You plugged it in, and that was all you needed to be able to receive the satellite. Just go outside, turn it on, away you go. Now, if we'd have had a project plan, we might have ended up something like this. I don't know if you've seen this particular project plan, but what I've really tried to keep in mind is the end game here. Something that's simple, just plug in, as easy to use as a Win TV stick. And luckily we didn't have a project plan, so we didn't do any of this piece. So how has it turned out so far? Hasn't come out very clear on here. But if you remember the USB dongle that I mentioned before, this is the block diagram of it here. What I have is a little device here which essentially makes the signal appear like a USB sound card. I also have in here a codec which I'm using as an analog to digital converter, and which takes baseband signals and converts them into a sound card format for reception on your PC over USB. And then the star performer in this whole piece is the front end tuner. So I'm using a silicon tuner, which is a tiny device about 5mm by 5mm, and this device costs around about £2 each in any sort of volume of say 1,000 units, and that converts the signal, the VHF signal coming from FunCube, into baseband. That's quadrature baseband. We have an onboard A to D converter straight into the PC through the USB. Now the other thing is I'm using a standard USB class devices, so there are no requirement for any device drivers. This just plugs straight into your Windows, your Linux. All the device drivers for this device are already on there, so there's no messing around with that. The other thing is it uses a standard interface that existing sound card software uses. So it's essentially a little bit like a soft rock, but for FunCube. One extra little piece on here, we also have a little tuning control here. In case we decide to change the sort of frequency that FunCube's on, we also have the option, because it's a silicon tuner, of being able to change the frequency this is on. And this is actually working. This is I've only managed to get this device around about, I think it was 10 days ago, get my grubby hands on one. And I think it was last Tuesday I actually managed to solder it in, get it all working, and lovely. And in fact, this is the prototype with all the spaghetti hanging out of it, which I said we wouldn't have. But we're hoping to get it in something around about the size of this. It's 3 chips, as I say, the silicon tuner is 5mm by 5mm, the codec's the same size, the USB chip is a little bit bigger, but we may be able to use a sort of smaller chip in the end. Now, total cost of these devices, all the silicon here, £6. So, you know, we've managed to keep the cost down. The other thing to add here, there's no SAW filters. I mean, a SAW filter alone could cost you £6. So we've got rid of the SAW filters. This is straight aerial, straight into the silicon tuner. All there is just an AC coupling capacitor. That's all there is. It's straight in there. The out-of-the-box noise figure on these devices is about 4 dB. So okay, it's not going to win any prizes, but 4 dB is not bad, and probably we won't need any sort of external LNA on it. Here is this is my software I use for actually decoding telemetry. Can't see it very cleanly there, but this is some telemetry generated by a device that simulates the real FunCube. In fact, it uses exactly the same source code, which is in FunCube itself. I've just recompiled it for a different device. So I guess best thing to do, rather than just talk about it, let's see it working. So, with that in mind, here's my USB. I'm going to plug it into the machine here. Hopefully it's going to go. Good, okay. I don't know if any of you have seen the program called SpectraView. I literally had not plugged this into this machine until about 2 hours ago. Where's your SpectraView? Here we go, got it. Okay, so let's start it running. Okay, now, as luck would have it, unfortunately there's a birdie in this room, just at the frequency that I was going to. This is 145.9, which is a bit unfortunate. And at the moment, I don't have the ability to. I haven't written a bit which changes the frequency of the silicon tuner. So we'll live with that for the time being. This is about 48 kilohertz spectrum here. I will warn you just here. These are some birdies which I have actually within the device itself. Possibly down to the construction techniques that I've used. I'm using smart boards. I don't know if you're aware of them, but they actually allow you to be able to do mixed signal audio and RF. They have a ground plane on them. You can prototype with them. Still not as good as a real PCB, but they're darn good for getting stuff done without a PCB. Because it's a quadrature output, you get the 0 Hertz thing here. If any of you have used soft rock, you've probably seen that. I haven't done any DC offset stuff on here yet, so that's still there. Now what I'm going to do is, just to show you this really is working, I've got a trusty FT817 here. There's no antenna, by the way, plugged in. It's just leaving bare. And on here I've got a dummy low. So, hello, golf, golf, golf. Let's see if we can get some noise out of this. Hello, 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 hello. Hello, 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 hello. Golf, 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 golf. Golf 6, Lima, Victor, Bravo. See if I can get some more. Golf 6, Lima, Victor, Bravo. Hello, hello, hello. So, that was at 145.9 megahertz. If you actually take a closer look at this board, there are no tuning slugs in there. There are no trimmer capacitors, totally no tune. It's straight down conversion from 145.9 megahertz. It's all there. And one other thing, in case you want to know what the telemetry is going to sound like on FunCube, I have a special little, another special little G6 LVB thing here. This here is my telemetry generator, which, as I say, has the same source code that we're running on the real life satellite, but all it does is just generate some telemetry for us here. Now I'm hoping this battery isn't dead because I was handed it by it a few moments ago, so we'll see. I'll just right, so there's a little signal there. This is what it sounds like. Okay, that's what it's going to sound like. That is actually, if it sounds a little bit like AO40 speeded up, i.e. with the sort of second or so of tone and then noise, that's because it is. We've basically taken the AO40 telemetry, and instead of running at 400 bits a second, we're running at 1200 bits a second. That's all we've done. Actually, there's a couple of little tiny changes, but essentially that's what we've used. We haven't used any new sort of newfangled technology. I did have some chats with Phil Kahn about this a few months ago, but his software wasn't available. Plus, of course, we have ITAR to think about. So we're just sticking with this, and for the time being, unless somebody changes it. One thing I should add on. Let me just go back to this thing. Oh, don't tell me I've got to go through. Come on. Oh. Okay, this is the deal killer here. This little puppy goes from 65 megahertz to 1.7 gigs. £6 worth of components. Essentially, it's a soft rock which covers VHF, UHF, L-band. The compromises we've got here, these are cheap surface mount parts, and in fact the USB device I got in there, the USB converter is 0.4mm pitch, the other device is 0.5mm pitch. It's not the kind of thing you kind of want to support from the point of view of people doing on the kitchen table. It also won't win any prizes for phase noise. This silicon tuner is designed for DVB-T, it's quite wide band signals, and we're actually trying to get narrowband signals. One of the benefits of using a codec, which is what you might find in a sound card, is they go through a process called oversampling, which allows us to actually refilter the signal coming from the more wideband DVB-T tuner and narrow down on that signal. But because these DVB-T tuners are not designed for narrow band, they don't really care too much about how good or bad their phase noise is to the same extent we might. So what effect does that mean to us? It means that if you've got an in-band strong signal, it will raise the noise floor. However, this has to be a reasonably priced device, fit for purpose, simple to use, cheap, so that's the compromise we've got there. Did we succeed with design requirements? Well, hopefully it is for everyone by the time we get into something like this. Is it true plug and play? Well, I hope you've seen that. I just plugged this right into this. I didn't have installed any drivers. In fact, SpectraView was what happened to already be installed on this machine. It will work with existing software. Low cost. Total cost of the hardware parts about £10. So that the three chips are about £6, and by the time you put them on a PCB and all the capacitors and resistors and whatever, let's say £6, something like that. But the assembled cost to be announced. If anybody has any experience of going into sort of assembly on these things, I'll be interested to talk to them. We're not talking about hundreds of thousands, of course, but we're probably talking in the hundreds or so, maybe hopefully early thousands, you never know. But hopefully we're going to get a device which is nice and low cost and something which is not off-putting to the average person on the street. As I say, we're trying to open this out not to the converted, we want to open it out to the unconverted. So that's the FunCube dongle, and hopefully that's explained it.
Okay, good afternoon again. I wanted to say a few words about the educational part of FunCube. That is the primary mission of FunCube, is to bring satellites to the next generation. And the reason for this is that this country and a lot of countries are suffering from a lack of engineers and scientists, and in a few years' time it will become to the point where it's actually holding the economy back. So there's already a shortage of engineers, and it's only going to get worse. There seems to be lots of accountants and bankers and people studying media studies, but that's not what the economy needs. It needs engineers and scientists. So let's hope that FunCube can bring along another generation. Just to give you some figures, there's about, in the UK there's about 1 million school sort of students per year group. So if FunCube goes up there and it's up for 10 years, we could get potentially 10 million people to hear FunCube. That's if every single school has a FunCube receiver. But that's just in one country. If you go to other countries, then you could have hundreds of million, potentially, people that hear what FunCube does. So even if just 1% of those people decide that it has an influence on their career, that's been worth it, well worth it. So we're trying to think a little bit about how the teachers can describe FunCube to students. So it's not something that people know about satellites. The only ways they do know about it is a sat-nav in your car, and they can see that, and they can see what it does, and they can see the benefits of it. They also know that they have a Sky TV, and they can see and it works, and they complain if it doesn't work. But they don't actually know what's actually going on to deliver that service to you. And school children always seem to be interested in wars and terrorism and bombs and things like that. So they might like to understand how satellites have helped, certainly the US military, to wage wars. So when the teacher describes satellites and what they can do, the next thing they want to do is go on to a demonstration, a little bit like what Howard just did, except they want to go and download the telemetry and actually see the messages arrive on their computer and go and process the data. So they've got the data from the science experiment that's measured the temperatures on the surfaces, and they want to go and plot that data out and make some sense of it. But first of all, they've got to understand what they're trying to do. So this, we don't think it can go necessarily into the curriculum, or certainly not straight away, but maybe it could start with after-school clubs, science clubs, anywhere, maybe even the last lesson of term, where most school children just want to get out and they're not listening anyway. So maybe just fit in a lesson on FunCube, or half a lesson, just so they get an idea of what satellites can do. But in order to do this, we've got to have all the material ready for the teachers. So it's all on a plate, and the teachers know exactly what they're going to say. But that's the one criticism from teachers, is any material they've got, it's got to be almost plug and play. This is what you say, this is what the questions they might ask. They don't want to have any complications or anything that they don't know how to answer. So it's that's almost the hardest part of FunCube, is bringing that message to the teachers so that they can then talk to the students about it. So here's an example of a student. Maybe he's got a bigger antenna than we're thinking of, but it gives you an idea of somebody can stand outside and they can hear the signals coming in, and they've got a receiver like Howard just showed, and it comes up on the PC, and then the teacher would display it or send it to all the other PCs. Maybe each student would get an email to say, this is the data that we've collected. So what we're trying to think about, and maybe what we're asking for your help, is how to get the message across to the teachers. How do we convince a teacher, well, this will be a fun project for you to do with your students. So we need to have teaching material already written out, maybe some video instructions on how to set up the ground station. What documents do they give to the students? What documents do they have for themselves to give the lesson? And how do we actually get the teachers so that they can plug it in for themselves. Obviously they try it out at home or after hours just to check they can really hear signals coming in. So how do we give the teachers confidence that they can actually get this to work? For a teacher who doesn't know anything about amateur radio, this is a big step into the dark. So if anybody can help on this, please come and talk to us and offer your services, particularly on the internet as well. One other thing is that there's a show, the BATC, a British Educational Technology Trade Show, and this is a big show, in fact the biggest show for educational technology. It happens in London, January next year in Olympia, and a good proportion of all the science teachers would probably come to that show. I don't know, 50% or certainly a healthy proportion, so that we can start to get the message out. So if anybody would like to volunteer to help us man the stand or prepare material to go to this show, it's a 5-day show, so it's not a small undertaking. And also we need help in how to set up receivers if we want to do trials with schools, just to see how it works out, how the material comes across. That's all something that we need help, and I've become a STEM ambassador, so you can't just go into a school, you have to go and you have to go and pass the CRB tests, and there's various schemes you have to go through so that you can't just walk off the street. So, and we also need help in creating the website and answering questions that people might have. There's a whole mass of work to be done yet, and we haven't really we thought about it, but we haven't started. So maybe somebody can offer their help. Please contact AMSAT to offer your help and advice. Thank you.
Thanks. I've just got to change the presentation. I'm afraid these slides are not very decorative, because I had to rejig them while you were listening to the previous presentation, more or less. What I've got? 5 minutes, that'll be fine. This is, I've called it CubeSim, this sort of project that I've been sort of doing on my kitchen table. It started off as sort of fun sim, and someone said, well, it's not really a fun cube simulator because it's missing bits, which I'll talk about in a minute. And my original idea was could I reproduce using one of these Arduino chips, which were mentioned in last Colloquium. It's a sort of little board that you buy for about 30 quid. Was it big enough and powerful enough and all the rest of it to replicate something that looked like the FunCube telemetry, not the BPSK or the modulation, but just the bit stream? And the answer was that it is, and it's got a bit of capacity to spare. And so I thought, well, that's sort of interesting. And I wrote a little screen display sort of thing for it, which I'll give you a glimpse of in a minute. And then it sort of developed. And it's actually developed into this. This is a rather nice Perspex case that was donated to me by the cookbook, CubeSatCookbook.com, which makes it look rather nice. And being transparent, it's quite good because you can see some of the inside electronics. I won't pass it around because it's not designed to be launched into space. It's quite fragile, actually. But I've got a few sort of shots of it. This is very much a work in process. This is very much a sort of prototype, and there are lots of other bits and pieces I want to do to it. Here are the differences in between CubeSim and FunCube. It's not made to go into space, as you can probably tell. It does have an up and down link, but it's not FEC, and it's not on amateur bands. It's actually on a little mini Wi-Fi sort of setup. It doesn't have as many sensors in, so a lot of the telemetry channels are sort of unpopulated. In fact, most of them at the moment. It doesn't have a material science experiment. It doesn't use BPSK FEC, which I said. It's much less complex, I can tell you that much, and resilient, and it doesn't have an antenna deployer. It's similar in so much it's about the same size and shape. It has solar cells, although they don't charge the battery. The TLM format is pretty much the same. It does have a ground station, sort of. It has a simulated antenna deployer, which are these two, which is a top board on here, as I'll show a picture in a minute. And it has the PCBs stacked on PC104 connectors, so it sort of looks similar to a CubeSat. Here are just a few pictures. That's a picture of the finished job. This is a sort of Mark 1. This is a sort of Mark 2 now. I've made the bits on Veroboard, and the bottom board. Well, I'll just go through, and I've got individual pictures here. This is the bottom board, slightly out of focus, I'm afraid, but that has the battery, a little battery charger thing on it, a voltage converter, and one of these current measuring sensors. If you go to sparkfun.com, which I'd never heard of until about 2 months ago, the number of different modules and stuff they've got is fantastic, and they're fairly cheap. I think the little current sensors are about £5 or something, and they're small, don't take much power, and even I could do it with my chubby fingers. So,
What's the website again?
sparkfun.com. This is this is an Arduino Mega, so-called, and it's actually not an official. It's a clone because it's slightly smaller than the main one, and that's the main processor on the in the simulator. The top thing where it says XB on its side, that's the Wi-Fi chip, and there's one in the satellite, and then there's one that just dangles out of the PC as the sort of the downlink, and you can see the PC104 connector at the bottom. Bit of a lash up still. That one hasn't been PCB'd yet. This next board was actually, again, I've got a Mark II of this, but this was the earliest of concept demonstrator, and all it is just 4 solar cells on each side. And the idea of this is because it's battery powered, you can actually put it on a little turntable, shine a light at it, i.e. sun, and then on the computer, on the ground station bit, you can actually measure the voltage of the solar cells, so you can plot the sine curves, and it would give a teacher who's unfamiliar with spinning satellites the idea that this is the sort of thing that they can do. Okay, and that is the last element, which is the top one with the 2 blue LEDs. That is the antenna system deployment. I call it a simulator, and again, this is a fairly early version. It's on Veroboard. I've got it on the PC now. It has 2 processors. Those are Arduino Nanos, which are connected via the bus, an I2C bus, to the main processor, and I haven't got mechanical bits of the antennas flying out, and so I just got a row of LEDs just showing what the state is. But it does replicate the actual commands on the I2C bus are actually the same as the ANT system uses, and the ANT system does have 2 processors like that. So I've tried to sort of replicate things for real where I can. This is just a snapshot of what I'm calling the ground station. The top frame is just a raw telemetry. It's slightly off the screen, unfortunately, but that is just displays the 256 byte blocks as they come in. I've got the solar panel voltages on the left and a record button, so you can actually dump it to a file, comma delimited, so you can import it into a spreadsheet. This bottom left is the antenna deployer controls. It has controls like arm, disarm, deploy 1, i.e. antenna 1. And it has 1 or 2 things I haven't implemented yet, like it has an activation count, how many times you try to activate the antenna, which is what the real thing does. And then bottom right is the fitter message display. FunCube will have 9 fitter messages you heard, so this does the same, and you can actually, the next one up you can actually upload different messages to it, just to give the idea to, say, teachers or whoever's looking at it, that this is how the thing should work. Here are my sort of ideas for how to complete it or progress it. I like to do whole orbit data and what we're calling fast TLM in the TLM stream. I want to replace the variables with PCBs so it looks a little bit more professional. I want to extend the ground station GUI and like the antenna deploy fields I mentioned. At the same time, I quite like to sort of what I call productionize it so it looks a little bit more professional. I've got to do something to the battery charging system, which is not quite good, and also make some housekeeping functions, which is the real battery voltage of that, so you can actually tell what it is. Does it need charging? I think that's about it. Thanks for your attention. I was going to demonstrate this in here, but it just got a bit too difficult time-wise. So I've actually got it set up outside if you want to go and have a look later on this afternoon. And I'll probably set it up tomorrow sometime so you can have a little look at the various plotting things and the telemetry types of things. That's it. Thanks very much. Any questions?
Any questions?
Done fine.
I think we've had some marvellous presentations from our three presenters. Are there any questions for any of them? Are there any on the net? No. Okay.
I'm impressed by this because you're doing the same things that we've been trying to figure out what to do. I know the American Radio Relay League has a CubeSat simulator that they showed at Dayton, which does some of the same things that your model shows. So I'm kind of curious whether or not you'd be interested in having any coordination with what has been developed from the league, or is it simply because it's trying to simulate the FunSat that you're pretty well set on what you want to do?
I'm happy to coordinate with anyone.
Okay.
This sort of thing happened almost sort of by accident. I was just finding so much fun doing it, to be honest, that I just sort of kept going and probably keep going, and I'll be delighted to.
And I guess my other question is, going back to STEM, are there any members that are teachers that would be willing to develop lessons plans? I mean, it's the development of the lesson plan that's going to be critical in terms of getting teacher involvement. Yeah. And that is something that would be helpful not just to the British teachers, but to anybody else who want to take advantage of FunSat.
This is one of the problems we've had with FunCube all along, is that we've had several offers of help, but I want to get involved. I'm a teacher. I'd like to do it. And then when you email them a couple of months later, it's sort of you get sometimes no response, or right. It's quite difficult. But we have got one or two people coming along. But to say we've got someone working on the lesson plans now would be misleading, I'm afraid.
Well, one thing that occurred to me that would capture the imagination of children and schools is perhaps to use a simulator as a way to engage children to create experiments in that space. So maybe, I don't know, you've thought about extending the simulator to have some element of modification that the kids or the teachers can do. At least if they saw it as just a pretend thing, but that'll perhaps engage them even more.
That's a good idea. I hadn't thought of it, but that's a good idea, and we'll think of it more. Thanks for the idea.
Any more questions? Yeah.
Jim, have you thought about putting a low power transmitter on it on 440 or something like that, so that you could then connect it up to this dongle? Have you thought about putting a low power transmitter on it, one of the ISM band ones, 440 megs, and then coupling that up with the dongle? You could then have a complete simulator.
Yeah, that's true. I have sort of thought about that. And one of the nice things about the Wi-Fi is it's license free.
So
and if the simulator takes off and the teacher wants to use one in a classroom or something, and it's on 2 meters, he can't, unless he's got a ham license.
That's why I say don't do it on 2 meters, do it at 448, where it is license free, and the ISM band, or well, whatever they call it.
Yeah, it's something that could possibly be done, but it's getting a bit too technical for me, but I think Howard's help. You're getting there, Jim, don't worry, you're getting there.
Any more questions? No, well, I think we should show our appreciation for those three very good things.